Hello, everyone. First of all, I would like to thank the organizers for inviting me to present Chemotion today. Um, before I introduce what Chemotion is and also how Chemotion would fit into a bigger picture of the research data management, I would like to give a brief introduction on how the data capture or documentation within the lab setup has evolved over the years. So if you look at the speed of evolution over the last few decades, then back in 1985, there's this great to supercomputer, which was having the capacity of 1.9 gigaflops calculations and also 244 megahertz. But over the years, now an iPhone has more capabilities around 325 gigaflops with 2.39 gigahertz of CPU speed. In the same time frame, if you look at the evolution of how data is captured within the labs, back in 1927, we have the data captured on physical notebooks, and now in 2019, it's pretty much the same. Um, but to understand the extent of this issue and also dig into the details of what was the key issues that has led to this NFDI for Chem. If you don't know what NFDI for Chem is, NFDI for Chem is an initiative to build an open and fair infrastructure for research data management. Yeah, and the vision is digitalization of all the key aspects in chemical research by supporting scientists in the process of collecting, storing, processing, analyzing, disclosing, and reusing research data, especially in the domain of chemistry. And we have conducted a community survey, and the main purpose of the community survey is to investigate the current situation regarding the research data management, especially in the major sub-disciplines of chemistry, and to understand the researchers in the academy with mainly focus on Germany. And the primary goal of this community survey was to ask questions and understand different aspects of the data management within the lab setup. And we have asked questions regarding what data are generated, and then what are the different formats, how do they generally archive the data, and then what information do they have about the policies in terms of research data management, and then the storage facilities, and then the experience. And the survey involved a series of questions with multiple options and also free text for the users to input in. And ultimately, the primary goal of this particular survey is to understand the requirements and wishes towards the national research data infrastructure and drive all the upcoming efforts as a part of the NFDI for Chem Research Data Management project. And the results are quite revealing, and which is not surprising to a certain extent for us, because the survey was mainly focused on all the disciplines or the hierarchies within the lab setup, starting from the professors all the way to the PhD students and other staff. And also focus was mainly towards the chemistry domain with sub-disciplines such as physical chemistry, organic chemistry, and various other sub-disciplines within the chemistry domain has been represented there. So if you see some of the outcomes or like an analysis of the survey results, you find that in majority of the cases, there hasn't been a proper setup in place in order to capture all the data right from the start electronically, although there has been some efforts. And also there has been a quite differences in terms of what information has been captured, especially when it comes to metadata. Metadata is mostly captured by hand, where it can be captured automatically. This has quite opened up a few gaps in the process of data capture in the research domain. And also we have looked into what are the different internal sharing habits, especially when it comes to the data that has been generated as a part of the experiments, and also what was the general procedures for the long-term data storage. So you can see in the two graphs here that internal sharing is mostly through internal servers. Emails are the next best, and then you have this long-term storage wherein the institutional servers are the places where all the data would actually end up in. So if the data is analog and it is sitting in hard drives, which I call it as in silos, and also if the data is just sitting in the servers at the universities generated from the different lab equipment, or if the paper results or the analysis are being published in journals where it is not machine readable, it's all not fair. In a way, it's kind of like reproducibility issue, and everything comes into play, which so if the data is not digital, it's not fair, and in order to verify the data, so the data has to be captured digitally all along the way, right from the experiment where the data has to be collected, and then the data processing, analysis, and then how the data is archived, and ultimately if there is any publication, are the metadata being machine readable, and then this data, whether it is being reused in terms of doing the reanalysis of the experimental findings of the experiment. So in the big picture, if you see, the devices generate all the data, wherein the electronic lab notebooks comes into play in order to capture all the data, and ultimately the data will be pushed into federated repositories. And then we have the data from different vendors, industries, and academia being able to convert it, and then the electronic lab notebooks should be able to capture all the subdomain specific modules, and then ultimately push the data to the federated repositories. So, why Chemotion? Aren't there any other lab notebooks that are currently available? Yes, of course, there are lab notebooks that are provided by different vendors or the lab equipment providers, especially Synode and lab folders. But there has been big gap in terms of providing functionality for research specific tools like chemical structure inputs and processing, and also the chemical reaction domains. And also there are several disadvantages of some of the solutions that are out there, which includes the solutions are not web-based, and there is no functionality in order to connect to the devices, and also most of them are commercialized to a certain extent, and they are not domain specific. So coming to the today's topic, electronic lab notebook, in which case, in this case, the Chemotion. Chemotion is an open source electronic lab notebook for chemists in academia, where the primary functionalities are aimed at data acquisition and processing, especially the chemical data, with main focus on the chemical structures and calculations based on the molecular properties. So the primary goal of the Chemotion was to support the chemists in terms of planning and description and storage and management of the routine work in the chemistry domains. You can access the Chemotion public instance by going to www.chemotion.net. And the primary goal, as I mentioned before, was to digitalize the data capture. Sorry, the animation is quite fast. Pause it. But this Chemotion instance is a web-based tool which can be installed locally at the universities, or the public instance can be used. And the primary goal was to capture the information right from the beginning, where you plan your experiment or the reaction directly on the Chemotion. And then you perform the experiment and capture the information all along the way. And then you add the metadata as and when you get the data from the experimentation. And ultimately all the spectra or the analysis can be directly captured on the Chemotion. Finally, the data can be pushed to federated repositories as and when they appear. So in this particular slide, you can see a typical view of Chemotion. So when you log into the Chemotion, you can structure your projects in the form of collections. So the collections are hierarchical in a way. You can add sub-collections to a collection, and then the collections can be shared with your colleagues so that the data is more easily shared across different members of the team and also across teams. Now, you can also sync collections, wherein a collection that is managed by you is also updated live with your colleagues. and you can share collections just like how you would share the data on a Google Drive or any other shared drives. Um, uh, at the core of the Chemotion, you see there are different elements. These are the key elements of Chemotion. So samples being the smallest organizational unit within the Chemotion, where it represents a chemical compound. And then you have the reactions where a combination of samples can be processed as reactants and the products with reagents. And then you have well plates, where several samples can be arranged in the form of a well plate, and then combined with metadata related to the application within the biology. Then you have screens. A screen is more of an overview of the biological experiment with several samples, usually organized in the form of well plates. And then you have the research plan, which is a summary of all the experiment that you have you're performing within the Chemotion. And recently there has been efforts in order to make Chemotion more generic rather than specific towards certain domains. And one of the outcomes of the efforts was being able to create generic elements within the Chemotion, which I'll get into the details in a second. So this is a different view of the elements that I have discussed before, where you have molecules and you have reactions, well plates and screens, and then there is this project plans. So if you observe here on the left-hand side, you have this sidebar where you have all the collections displayed there. You can add your own collections and then add sub-collections to the collection. The collection can also be transferred between users within the infrastructure or the Chemotion infrastructure. And you can add a new chemical or the molecule to your chemical database by clicking on the plus sign here. And once you click the plus sign, you can add in details about the small molecule by using an online molecular editor, or you can key in the molecule name or the INCHI keys or all the specific details of the individual molecules. These molecules can then later be used in order to document reactions, wherein you can specify what are the starting materials by selecting the specific small molecule, and then you can specify the reactants and the products. So alongside with capturing the details of the reactants and the products, you can also specify what are the concentration levels and few other experimental details right away within the Chemotion itself without having to use the physical notebooks. Another key aspect is being able to document directly within the Chemotion without having to use a third-party tool. So Chemotion is equipped with a lot of functionality in terms of report generations. These reports can directly be exported to the supplementary supporting information within the publication that you would do. And also, not only you can perform a search within the Chemotion instance, but also you can, within your chemical database within the Chemotion, you can also perform search by connecting your Chemotion instance to third-party databases such as SciFinder or PubChem. Right now, SciFinder functionality is available only on the public instance of the Chemotion, but if you are planning on installing Chemotion instance of on yourself, there is some development in progress at the moment in order to facilitate this. Chemotion is quite modular and robust, so any third-party developers can develop additional tools in order to assist researchers along the way. Here is an example of Dft Calculations, which is a plugin onto the default Chemotion infrastructure. Here is another example where you can perform retrosynthesis, where the starting materials can be directly predicted by keying in the end product. As I mentioned before, initially the Chemotion used to have a few generic, few elements, but now efforts have been put in place in order to make it more generic. So you can now find on Chemotion generic elements where it doesn't have to be related to chemistry alone, but if you are capturing information that is structured in the form of a document, then you can possibly reproduce the same structure within the Chemotion and capture the information all along the way. Here is an example where you have a generic element and then there are multiple layers, which is more like a typical form that you would fill online for any specific purposes, in a way giving you all the flexibility to plan or decide the layout of the Chemotion that you work with. So here is a real world example wherein the generic elements are used to generate a template, especially to fit the purposes of a polymer chemistry. Here in the demo, you can see that the user is keying in the polymer, and then you can also see the different steps all along the way, how the metadata is captured and how the data is extended further. So moving on, if you are interested in the technical aspects of how or what's the technology behind Chemotion, Chemotion is mainly based on Ruby on Rails, which is a programming language. And then the front end, the UI that you see is built upon React, and then these communicate via an API, and you should be able to interact with third-party external services such as the SciFinder or PubChem and NMDB. And also there are importers and exporters in order to import your SDF files or export your data in the form of an Excel sheet or PDFs. If you are interested in installing Chemotion by yourself, there are two recommended approaches. One is the native installation, wherein you have the traditional monolithic approach, and then you have the advanced, more state-of-the-art Docker installation instance also available. All you have to do is clone the Docker instances and then spin up your own Chemotion servers. So at FSU Jena, we have our own Chemotion instance, and if you are interested in using Chemotion in capturing your data during your experimental process, then you can use the instance that is dedicated for FSU. And if you are interested in also receiving updates on the latest advancements within the Chemotion instance, especially at the FSU, we have the mailing list where you can subscribe. We also have a YouTube channel where all the functionality under the different features that are available within the Chemotion have been documented, and we are open for more suggestions and also happy to extend this documentation further. And thank you for your attention. I hope I'm good with time and open for any questions that you have.